How's it going, everyone? Welcome back to the channel, and in this video I'm going to be talking to you about the Hubble Space Telescope and how it has found something interesting and a bit strange around the object 3i Atlas. So let's get into the video. So new images from the Hubble Space Telescope have revealed something very strange and unexpected is happening around the interstellar object 3i Atlas. Instead of behaving like a normal comet, this object is showing a powerful sunward anti-tail and a set of perfectly spaced jets shooting material into space. These features don't match what our current comet models predict, and they're raising serious questions about what this object is made of and how it's built. In this video, we'll break down what Hubble actually saw, why astronomers are surprised, and what scientists hope to learn next. So let's dive in. On January 14th, 2026, Hubble captured 6 detailed observations of 3i Atlas just after it passed perihelion, the point where it's closest to the Sun. That's when heating is at its strongest and comet-like objects usually become very active. Using its WFC3 UVIS camera, Hubble imaged a cloud of dust and gas around the object, stretching more than 130,000 kilometers. But one detail stood out immediately. Instead of the cloud being pushed away from the Sun, like we expected, the brightest extension of the material was pointed towards it. Sunward features do sometimes appear in comets, but they're usually faint, short-lived, and caused by viewing angles. This one was bright, broad, and stable, which is a bit unusual. So now let's talk about the jet pattern. To get a better look, astronomers process the images using a method called a Larsen second rotational gradient filter. This removes the smooth glow and reveals fine structures. What appeared was very striking. One dominant sunward anti-tail, 3 smaller jets, each jet spaced about 120 degrees apart. Normally comet activity is pretty messy. You get cracks that form randomly, sunlight hits unevenly, and jets turn on and off unpredictably. But here the jet looks organised, almost like the object has a structured system controlling where material escapes. Even more interesting, during the 30-minute observation window, the pattern didn't change much. That suggests the jets are tied to the object's rotation, not random blast. So this very much looks like a stable rotating outflow system. Now, why does this challenge typical comet science? In typical comets, sunlight heats the surface and then the ice melts. The ice turns into gas. Then solar system radiation pushes everything away from the Sun. That's why comet tails usually point outwards. But 3i Atlas is doing something different. Its main feature extends towards the Sun, resisting the Sun's radiation pressure. For that to happen, the material must be different. Scientists think it could be large chunks of ice with enough mass to resist being pushed back, or unusually large dust grains, much bigger than normal. Either way, this is not your standard comet debris, this is something else. So let's have a look at some composition clues. Before the object got closer to the Sun, a mission called SPHERE-X detected ice on its surface, and this happened after it passed closest to the Sun. The icy signal mostly disappeared. Instead, astronomers detected something different. Lots of organic molecules in the gas, a big increase in water being released. This tells scientists that the Sun's heat likely exposed deeper layers inside the object. For fragile organic materials to survive for billions of years in interstellar space, they would need to be buried under thick protective layers. So this object is probably not just a loose mix of ice and dust. It likely has solid structure and multiple layers inside. So we've seen a couple of times objects come from outside of our solar system, and each time they come in different forms with structures and materials we don't actually normally see. So we don't know what we're looking at every time. It's not predictable, and it tells scientists something very important. You can't predict what we're going to see. So as 3i Atlas moves further away from the Sun, astronomers will keep watching. They want to see if the unusual anti-tail fades away quickly, or if it stays stable over time. If it fades, it might mean the Sun only exposed a temporary layer of material. If it stays, that suggests some deeper features inside the object are actually controlling the activity. Either way, these results help scientists better understand how interstellar objects form, change, and survive. So the Hubble Space Telescope's images have actually shown 3i Atlas does not behave like a typical comet. It has a stable tail pointing towards the Sun. The jets are spaced evenly around the object, and it's also got signs that deeper material was exposed. Whatever the final answer turns out to be, this object has already reshaped how scientists view interstellar vistas. It reminds us that space still holds many surprises and that objects from other solar systems may be far more complex than we ever imagined.